So I want it spot repaired and load tested. Or if you refurbish these 50 to 75-year-old bolts, like you did your roof and your windows and your door and your boiler in the building and your sprinklers, then you just rattle all these things. He says, I think this bastard child needs a little bit of attention right now, and I will forego the load test if you give me what? A full refurbishment. And if they replace it, any load test required? 100% replace it. They need a load test? No, because the engineer has already given you the documentation through the permit process. Yes.
During the refurbishment on the step trailers.
Yeah.
The thickness of the metal which the bolt goes through, if that's degraded,
yeah, very rare.
You have to replace the stair.
Of course, yeah. Any tread that's bad, but you're going to find fire escapes are very forgiving, and a lot of times it takes a quarter inch piece of steel will grow to 1 inch of rust. Okay, that's how much you're going to get. So a lot of times when you have rust between a connection, when you clean it, there's still plenty of meat left. You still have 80–85% left of all the steel still there. Even though it looked like a lot of rust, it ate very little of the metal because rust is 4 or 5 times the size of the actual piece. And it never gets that. So, and your structural engineer answers that. He will replace certain components, including treads or stringers, if they're all eaten through. Here's your other big question, guys, right? This is the I can't see it, right? So this is actually in a 20-story building in Chicago, and it passed the visual inspection. But then one of the structural engineers says, you know what, let's do some spot inspecting, and let's have the mason blow out some of these bricks. And he did. This veneer is not structural. See this veneer right here? That's just the skin of your building. You can use vinyl, you can use clapboard, you can use brick. Where this fire escape ties into is this other thing called the masonry wall on the inside of your veneer. That's what I'm tied into. I go through the veneer. The veneer is not structural. This is structural. But when the parapet wall has a hole in it for 50, 75 years and it leaks down between. See that little cavity right there? Which is usually a 1/2 inch or 3/4 between the veneer and the masonry wall, and it has these little clips that hold the wall in place. The wall is nothing but a skin. But when the water's coming from the roof for 50 to 75 years, guess what it eats? It eats the inside. Look how fresh and beautiful that steel outside looks. See all these dragon tears over here? See all this rust? That's a telltale sign that stuff is going on inside and it leaked out. It tears itself out. But until you open this baby up, I can't verify it. And then if I open it up, I find nightmares. Guess what we have to do? Now we've got other problems and other things. And this is $200 to $400 a piece to have a mason do this, because he has to put the bricks back beautifully, and $200 to $400 per connection. If I take the same connection here and about 5 inches away, I drill a 3/4 hole, 8 to 12 inches deep, put in an epoxy bolt by Hilti or some other top brand name company, verify that the hole is properly connected. But again, I've got 12 of them I'm putting in. Even if one fails, the fire escape is not going to fall down. But I epoxy bolt them in, and then I mechanically fasten this bolt back to the clip. The cement one that I had, that I saw some rusty tears and stuff like that, I basically packed it and I left it and I sealed it so no more water gets in there. So I let sleeping dogs lie. But do I need that connection anyway? If I have a brand new epoxy bolt, 3/4, 8 to 12 inches buried into the wall with engineer oversight? So I'm only burying and letting sleeping dogs lie because the building is 75 to 100 years old. If I want trouble, I just have to keep looking. But if I reconnect it, which is only about 2 to 3% of the entire structure of a fire escape is inside the wall, I've just nullified it. I nullify the need to load test it because I put in new epoxy bolts. So I say, please, Mr. Inspector, I've nullified the connections into the building with new epoxy bolts or new pressure plates, sandwiches, with a plate on the inside. And every bolt on this fire escape, which is 50 to 75 years old, I changed every bolt out. I've also signed on the document that there's no rust in any one of my connections, and any connections that we did open up and that we have, we sealed it with 50-year silicone. Please, Mr. Inspector, can we avoid the load test for my client? Your answer should be, have you been satisfied that this thing is back to a new line in the sand? Day one. And it's fully painted. So that's all we're talking about every time we have one of these classes. You guys need guarantees. Load test will get you guaranteed. What else will get you a guarantee now? Spot repair and load test is getting good. What else will satisfy you? I don't want to do the load test. It's too expensive on this building. What else can we do? Refurbish it? Seal all the connections? What about the wall? What do you want me to do to the wall? Verify or duplicate? Verification, let's see what that looks like. Let me drill some holes in it. Look at all I have to do. The same 3/4 drill, I have to drill not one, but sometimes 2 holes. So I can stick this snake down the thing and look at these connections and verify a piece of steel stuck inside to the best of my ability. Why don't I just take that same drill and about 5 inches over there, drill the same 3/4 hole, throw an epoxy bolt in there, 8 to 12 inches deep, so I'm picking up the masonry wall, re-clip it back to pick up this angle with whatever angle clip I can devise, make, or generate. Keep the original and make sure it's packed, which that one was anyway. There was nothing wrong with this one, but you needed a verification of load test it or verify it. So I went, this is that California craziness. And oh, there's some other stuff inside. This looks like the inside of a horror chamber. I don't know what I'm looking at. But I needed to photograph and verify. Wouldn't it just be cheaper to duplicate the connection? Because those you can do for about $50 a whack. Make sense? So, this is the plate on the inside.
Is that the plate for your epoxy bowl?
No, I'm going to show you in a second, but there's only 2 ways for you to have a fire escape stick to a building. 3 ways actually. The first one is the most simplest one, legs to the ground. So you just lag bolt it back to the building. The building is a leg, the leg is a leg, you have a little bridge in between. That's a fire escape. You see a lot of those which are just legs to the ground. The next one is now, the fire escape is attached to the wall in some way. If it's a masonry wall, it's usually cemented into a pocket, and I'll show you that. If it's a wood structure, it's got to have a plate, because you have to have a sandwich. A plate on the inside picking up studs, the nut on the outside picking up the support. That's the only 3 ways you ever have a fire escape done. Occasionally, on some masonry buildings, they came through, which on the picture before showed a plate on a masonry building. That's not a very normal occurrence. Normally it's cemented in, you can never see it from the inside. But every now and then you got this plate. It's just an abnormality, but it's acceptable, meaning a masonry wall that some guy just blew a hole all the way through, and because the wall was open, a lot of times my walls on the inside are not exposed like this is. There's walls there, there's sheetrock there, there's cabinets there, and it's faster for me to get on the outside and just put a new epoxy bolt, be done with it. But in some mill buildings, I'll have full exposed interiors, and it's just give me a through bolt and put a plate. Okay? We're doing a job over there, we're watching a job in Rollinsford, New Hampshire. And one of the mills, right down in the downtown. And they're through bolting everything. Okay? This is a little bit of load test. I needed almost 3,000 pounds. I used the back of a truck which weighed 7,000 pounds. I had a cable that went through the building, through every one of these, and then it plated, and it strategically had that angle going across so that I was able to pull on this cable 3,000 pounds. And how did I do that? I did that with a chain fall, 10 stories. Everyone had to be measured and taped and photographed and videotaped. You know how much money of that buys bolts or paint for the client? None of it. So that's why load tests, are not the most economical way of taking care of your fire escapes. You have to repeat that every 5 years. But now, let's see a little bit of the noise that's associated with, all the measuring can't deflect more than 3/16 of an inch, and I got to put that in my criteria to you. And guess what? Start lifting the tail of a truck. Now, if this thing fails, who's going to get conked on the head? The guy without a head. Well, thank God we were doing the 9th floor. But prior to that, but good observation, because there's the hard hats that we're supposed to be wearing. But again, it's very dangerous work. But that's why you load it with 40% first and then the remaining 60%. Because you got to check for deflection, any pops, any noise. This is us in communication with our engineers who have given us the oversight on what needs to be done. So we were actually live video feeding this to the engineers back in their office. All basically to verify this. Missing pieces of a fire escape. Fire escape that you can't get through. This is a fire escape case that we did where a fireman basically fell through. He was supposed to go to that 3rd floor. He fell through that, I believe it was this staircase right there. 2 or 3 steps gave way right there. 27-year-old fireman fell through, went back up, got the woman and the child out. Then by the time he was all done, he had severely injured his spine. Done. The uniqueness about this case is that this wasn't a disability case. This became a case where he sued the owner directly for negligence. Because he didn't get hurt during a routine accident of a work-related activity. He got hurt because the owner hadn't maintained his fire escape for over 25 years. Is that an accident or negligence? He was able to go in and sue the owner directly and all his assets, and they quickly settled. When we got there 2 years later to do this final inspection, basically what we found is that the fire escape, the rest of the fire escape was in the same condition as the original accident date, but those 2 or 3 steps that he fell through were rebolted. They quickly settled after that inspection, but from it came this great class. Let me give you a quick lesson on how rust grows. I'm about to prove to you that when you get to a fire escape, that it rusts from the inside out, not from the outside in. If I can prove that to you, and every time you walk up to a fire escape and it's got a lot of rust on it, it's going to take at least 25 years of unchecked, unpainted activity for a fire escape to get fully rusted. So if you get to a fire escape and it's fully rusted, I'm going to show you how you can say, because of a class, that every connection on that fire escape has been compromised, and it now can only be verified in one of 2 ways. The first one is the dirty word, go ahead, say it. Load test it. And the second way is refurbishment. And who's going to tell you that? Your structural engineer, because you're not touching this thing. The owner's not touching this thing. The owner's nephew, cousin, friend who knows a lot about structural things, right? You want to load test it or you want it refurbished. Because the fact that he's let it rust for 25 years, is every fire escape connection on that building compromised now? To what degree? I don't know. That's what the engineer is going to tell me. But I can know once you load test it to what degree, but that's what the structural engineer will work out with me. So now let's talk about the life cycle of rust. Every fire escape in the world, every piece of steel in the world, every bridge in the world got put together with 20-foot lengths of steel, cut to a certain size, and then those 2 pieces got put together. They got put together because somebody popped a hole between the 2 and they attached it with a rivet when it was 100 years ago, and then they started attaching it with square bolts 75 years ago. Do you think they painted the 2 pieces of steel before they put them together? You guys ever sweat a copper pipe with a blowtorch? Doesn't it look like it's wet when you start hitting it? Steel is wet. There's moisture. So whenever you put 2 pieces of steel together, pop a hole through it, put a bolt or a rivet on it, and then you paint it all around, where's the only unprotected piece of steel? In between. Now, as the temperature every day, as you get heat and moisture, do you think that starts sweating on the inside there? That sweat turns into rust. All rust needs is air and water. What's it getting when you put 2 pieces of steel together? It gets air and water. So how do you stop it from getting any air? You seal it up with what 100 years ago? Paint. So as long as you keep it painted, it'll never get the second thing it needs to grow rust, and that is air. So 100 years ago, 75 years ago, you're supposed to keep your fire escape painted on average every 3 to 5 years. Have they? Every seal on a fire escape has broken, allowing air to get to those unprotected pieces. So that's what you have here. Whenever you have pieces, and that's a paint job right there, okay? a little bit of surface rust gets in there. It's trying to break in because the seal cracked of the paint. What you were supposed to do 50, 75, 100 years ago was lightly wire brush it and do what every 3 to 5 years? Paint it, creating the seal. Did anybody do that 50, 75 years ago? No. So they let it go to the next phase. You basically painted over the rust that was there. It was light surface rust anyway, right? So I'm sure there's a glob of paint I'm going to throw on it. It's going to do what? Seal it, right? So what happens whenever you paint rust? The rust eats the paint. So the first thing that cracks, again, is the joint that you thought you were taking care of, but nobody wire brushed it. And all of a sudden, now that rust went and it went all the way through the entire connection of the tread. It's got a 1/16 or an 1/8 of rust all the way down. Is that connection compromised? The shaft is still there. 50, 75, 100 years ago, the shaft is still there. Will it fall with that 1/16 to that 1/8 in there? No. Got a piece of shaft. I can put a piece of wood in there and it won't let the thing. It's a block. But I've got an 1/8 to 1/16. So, you know, about 50 years ago, were you safe on fire escapes that had rust in its tread connections? Were you safe? You bet your ass. So nobody was really, man, I see a little bit of rust, but man, this thing is solid. So fast forward another 25 years. Uh-oh. Now we're 50 to 75 years later, which is today. There's a 1/4 inch of rust in there, and that rivet is only so long. It's only 3/8 long, and you already pushed it away from itself 1/4 inch or more. So you're dangling, all this piece of angle needs is that piece of angle to hit a little bit of that rivet. But it's already been pushed out. That's why you asked me, you know, do you care about what bolt you use, whether it's, you know, stainless, whether it's, you know, a rated bolt? No, because what kills a bolt is the fact that the iron is eaten, and as soon as you push it away from the bolt shaft, the tread wants to pass through. That's your problem, not the bolt. So all of a sudden, and this is evidence from the case that we did. You step on it, tenants step on it, they fall through. Firemen step on it, get jammed up with all their gear. Now you're fighting fires or rescue mission? We were going back up, right? During our case study and investigation. This is how much rust was on that fire escape that the firemen fell through. And as we're going up to look at the stairs, treads were falling underneath my feet. So this is all being videotaped and photographed as we're doing it on the fly. So the lawyers are there, their lawyers are there, and we're walking up this fire escape that almost killed a fireman, and it's all rotted. Except for those 3 treads that he fell through. Those got rebolted 2 years ago. So as I'm going up and I'm stepping up, I'm just stepping on treads and I'm falling through again. I'm like, hey dude, what's going on here? They didn't refurbish this fire escape, right? They settled the case. Let me just go back up on. This is the thing I talked to you guys about. I'm going to show you how fire escapes are built, but before we get there, I just proved to you that fire escapes rot from the inside out or the outside in. Everything starts at a connection. So you walk up to a building and the whole structure, rails are rusty, stringers are rusty, the grating is rusty. You have a paint problem or a structural problem? Structural. Because what you have right now is you know where it came from. Is it eating from the outside in or the inside out? And is every connection suspect? That's all you have to know. Do you know which one is suspect? Who's going to tell you? An engineer is going to tell you. But you know right now that every connection is suspect. You're going to immediately order a load test. What does that load test automatically bring in conversations? Right? Load test your fire escape. Like what? That's going to open up all the questions, right? Right of violation, load test, fire escape. Or you can write that other one that says repair, paint, test. Right? But otherwise, any call you get from the owner, any call you get from a structural engineer, any call you get from the mayor, any call you get from anybody, every fire escape must be load test. Or give me other satisfactory means to avoid the load test. So most codes, and again, I've got the book over here, and I'm going to pass the book around because fire codes and building codes, and you guys are NFPA 5th, it's Quincy, right down the street from me. I live in Somerville, Massachusetts. I need some of you, one of you guys to tell me where you're going to write your violation out of this life safety code. Because they say it's here. There's 107 pages of it. So somebody tell me where it is in here, and then I can try. Oh, there you go. Please find it for me. In the meantime, let me tell you what every state code, every building code, and every fire code says. And once he tells me exactly where he would write a violation from, he's going to give me some. Does anybody here remember some of the code numbers they used to write a violation? Because then we can go right back to that. But let me tell you, this is New Jersey, ready? 1028.6, it's a fire code. So it's the International Fire Code of New Jersey, so they're using the International Fire Code. Let me read what it says, and I'll read it here off the, you guys have the tags floating around there, if I may. Let me tell you what it says here. I'll put your code right there on the bottom for you. Ready? 1028. This is actually this is the building code, and I'm going to read you the fire code. Ready? A building code out of Massachusetts says testing and certification, all exterior bridges, steel or wooden stairways. Did I mention fire escapes yet? So this is beyond. Most of your code is actually beyond. It's all exterior egress, isn't it? Thank you. Where would you write your violation? Right, but what for the maintenance? Where would you write your? I need you to write me not to build one. I want to repair one. If you found the violation or a problem, just point out the code. So right here, egress balconies. Fire escapes, egress balconies shall be examined or tested. What's that word mean? Examined and or tested. So who has that choice? The structural engineer or you? That it'll be examined and or tested. Very good. For structural adequacy and safety every 5 years by a Massachusetts registered professional engineer or others qualified and acceptable to the building official, meaning, can we send you credentials for a fire escape engineer or fire escape inspector? And if you still don't like us, we piggyback with a structural engineer. And then said engineer shall then submit an affidavit or to the building official. Now that's a building code right here in your sister city. You may want to copy that and say, I want to use it up here because I like that building code. Let's take a look at the International Fire Code 1028.6. Exterior egress. All exit discharge. Sorry, I say fire escape yet? Exterior stairways that cover all those dirty porches on the back of the building. And fire escape shall be kept free of snow and ice. Any fire escape or exterior stairway found to be in a state of deterioration or determined to be unsafe by the fire official shall be repaired immediately. Depending upon structural condition, a load test of any fire escape shall be conducted before the fire escape is returned to service. So, depending upon structural condition. Who decides depending upon structural condition? A load test will be ordered. So, who decides and who can order? It's you guys. So, otherwise, stick with the word load test your whole life. Otherwise, you say the word depending, because depending on what code they're going to pull out somewhere, and he's going to give me a code there because he's still looking for it. Because a lot of times the code will tell you how to build a new one. They won't tell you how to maintain it. But here's two building codes, a building code and a fire code, and don't they say the exact same thing? Examine it or test it. And it says right here, depending on the structural condition, a load test of any fire escape shall be conducted. So the word depending now is, you're able to play with that word. How would you like to play with that word? Somebody has to go out of their way to satisfy you, don't they? So some structural engineer will make it's a priority for him. Just like your sprinklers are a priority, your smoke alarms, and your central station, and your fire hydrants, and you say, so what are we doing about this fire escape? Oh, we're going to scrape it and paint. He goes, oh, an opinion. So it's in your opinion, it's unsatisfactory. Just load test it then. Spot repair it, give me a load test, call me the day you're going to do the load test. I want to see what it looks like on the ground. Well, what's going on, Any other options besides load test? Yeah. You can spot repair it, and then load test it. And do this every 5 years. Or, we just refurbish this thing because, when the last time they changed the roof over, right? When the last time they changed all these windows up. You probably know when they changed the boiler out. And yet this thing that's been out here catching rain and wind and snow for 75 years has all its original hardware still on there. Of course I want to load test it, because it's old. But if you refurbish it, you're probably not going to do it. I'm not going to load test this thing or ask for a load test for another 25 years.
This is the greatest in the world.
Oh, he's got something. He found something.
But if you read that one right there, and then if you go to that one right there, or reading that.
Fire escape stairs shall comply with provisions unless proof of existing fire escape stairs, comes with any.
And then read that bottom one and that third one.
Yeah, Mr. Jefferson's right there. The authority having jurisdiction shall be permitted to approve any existing fire escape stair that has been shown by load test or other satisfactory evidence to have adequate strength. Well, guess what? Thank you very much. We taught a class in Newport. They use the same, Rhode Island, and they use the whole state, same book. And we asked, can somebody please, and so I said that this will most likely match. We just matched the words that I said there, right? So your code, by the way, write this down, 7.2.8.6.2. I'll start again, ready? 7.2.8.6.2. You guys get one whole line. That basically we just taught in this class. The authority having jurisdiction shall be permitted to approve any fire escape stair that has been shown by load test or other satisfactory evidence to have adequate strength. Did we say anything different in this class? So somebody calls you up and says, hey, there's a fire escape on Tremont Street, what do you want to do with it? You say, load test it, or give me other satisfactory evidence to have adequate strength. Would a refurbishment satisfy you guys? Including the whole retying it back into the building, duplicating it or verification? So that's it. That's it. You guys have basically walked into, thank you for showing this, because now I gotta find this piece right here. And everything else is all about building new ones. And all of a sudden, one paragraph and how to fix it. And if somebody didn't explain that to you, didn't explain how much power you have, that you must be satisfied. Because every now and then I have to satisfy a building owner. Oh, right, 30 years I've never touched this thing, I'm not going to touch it now, and that guy's crazy, and I'm going to call the mayor because the mayor is my third cousin twice removed. What are you going to tell the mayor? He doesn't have to fix it. Just have him load test it. The code, 7 point, da, 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 da. What do you want? Not let the guy have sprinklers either? Give him a free pass on a bunch of other things. We're only talking about tenants and firemen's lives here. What the hell, Mayor? You know what I'm saying? Otherwise, specifically in the code, I'm giving the guy a break. You can either load test it after he does some spot repairs as under the advisement of a structural engineer, or you can just refurbish it because it is old. Well, what happened? Oh, the thing's only 25 years old. Well, then, the structural engineer, photographing it, inspecting it, sat down with me and he showed me that the thing is only 25 years old. And I didn't order a load test because he gave me satisfactory evidence that it had adequate strength. So in this 5-year cycle, I'm not ordering anything. The certificate will suffice. But that's the front fire escape, Mayor. The one on the back in the alleyway is 75 years old, treads are dangling, and this guy wants me to give a certificate for both sides. It ain't gonna happen. So that's what this class is all about, is finding where you have the power. So who has the power to oversee what gets done to a fire escape? The owner, the structural engineer, or you? It's you guys. That's all you guys need. We have the power. I'm sorry, guys. So that's how deep it is into the building, 8 to 12 inches deep. That's a cemented pocket, and that's it. That's what it looks like. Okay? See? 2 staircases, dangling treads, and where's the brace? Somebody took it out and into the back. As soon as you step on that, if it's only 8 to 12 inches deep into the wall, how much weight are you going to need to rip it out of the wall? This is the typical. It either has a single bolt there or it has a gusset. But it's still only buried 8 to 12 inches deep. This needs to be refurbished, and that needs to either be verified or duplicated. This is what happens when water gets driven into the bricks. This is what it looks like on some of the interior of some mill buildings.